Hello everyone, welcome to my channel Essentials of Electronics. Today's video is based on an important oscillator, RC phase shift oscillator. Why the name RC phase shift? We have three sets of RC elements connected which behaves as a feedback path which will help us to generate the output waveform. So I'll be drawing the circuit of an oscillator here. The emitter terminal connected to RE and a bypass capacitor C. We have a voltage divider bias kind of biasing connected to VCC and three pairs of RC connected in such a way that these pairs of RC circuit generates output waveform. Yes, we have RC, R1. Let this resistor behave as R, R, and the capacitor C, C, and C. So these three pairs of RC forms the feedback which generates a signal which is in phase with the signal which is generated by the VCC. So the DC power along with the RC components in the network generates a sinusoidal wave without any input signal. Yes. So the RC network is used in the feedback path. In the oscillator, the feedback network must introduce a phase shift of 180 degree to obtain total phase shift around the loop as 360 degree. Thus, if one RC network produces phase shift of an angle of phi is equal to 60 degree, then these three pairs of RC network produce a total of 180 degree phase shift. Hence, in the RC phase shift oscillator, the feedback network consists of three RC sections, each producing a phase shift of 60 degree each. Thus, the shift due to the feedback is 180 degree. This is shown over here. So to determine the frequency, this is a RC phase shift oscillator is an example of audio signal frequency. To determine the value of the frequency generated by the signal. Yes, we need to analyze the circuit. Yes, we'll move on to analysis of the circuit. The three pairs of RC components. I'll just draw a simple equivalent circuit of the elements of the feedback path. VI, three pairs of capacitors, R, and R resistors, and we have V0 is equal to Vf. Let them be three loops of the circuit. Let the current I1, I2, I3 be flowing in the three loops. Then we can form a matrix with this R plus 1 by SC minus R 0. We don't have any element connected to the first loop and the third loop, so we have a 0 minus R 2R plus 1 by SC. The second parameter and minus R 0 minus R and 2R plus 1 by SC. S into I1, I2, I3 is equal to V1 because we have the source only in the first loop. Yes. So after this, we just need to go in for the complete analysis to find out the frequency. 1 plus SRC into 1 plus 2SRC square divided by S cube C cube minus R square into 1 plus 2SRC divided by SC minus R square into 1 plus SRC divided by SC. So from the matrix, we have developed the required equation. After this, we need to go in for the analysis of the circuit. We need to simplify it. Is equal to 1 plus 1 plus SRC into 1 plus 4 SRC plus 4 S squared C square R square minus R square S squared C square into 1 plus 2 SRC plus 1 plus SRC. The whole divided by S cube C cube. On simplifying this, we will be getting 1 plus 5 SRC plus 6 S squared C square R square plus S cube C cube R cube divided by S cube C cube. Now simplifying and writing in the form of a proper matrix. 1 plus SRC divided by SC minus R V1. Second group of elements minus R 1 plus 2 SRC divided by SC. For easy simplification, it has been listed out in this manner: minus R 0. And the I3 value is equal to T3 divided by T. Why I3? Because we are obtaining the output voltage across that loop. Vi R squared X cube C cube, the whole divided by 1 plus 5 SRC plus 6 S squared C squared R squared plus X cube C cube R cube. So when calculating the beta feedback ratio, V0 by Vi, V0 is equal to Vf is equal to I3 into R. So the equation to be multiplied by R. And replacing S is equal to J omega, S square is equal to minus omega square, S cube is equal to minus J omega. Then we will be getting beta is equal to minus J omega cube R cube C cube divided by 1 plus phi j omega CR minus 6 omega square C square R square minus j omega cube C cube R cube. Now, in order to find the value of the frequency, the real parts and the imaginary parts can be equated separately, and then beta is equal to 1 divided by 1 plus 6j alpha minus 5 alpha square minus j alpha cube. So following this, we are towards the end of the analysis of the oscillator. Alpha into 6 minus alpha square is equal to 0. Alpha is equal to root 6. Therefore, 1 by omega RC is equal to root 6, and omega is equal to 1 by RC root 6, and F is equal to 1 by 2 pi RC root 6. This is the expected frequency of the RC phase shift oscillator. In many of the textbooks that you people are following, we will not be having the complete analysis. I hope this video had achieved in obtaining the information about oscillator and the complete analysis on determining the frequency of the RC phase shift oscillator and audio frequency oscillator, which generates 20 to 20 kilohertz of frequency. Thank you.